From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
What we do over here is research and development work across polymers, composites, manufacturing processes, and then additive manufacturing, and then even some digital design work that we do. So I work more under the additive processes.
That was Sabina Kumar. Sabina is a lead additive engineer at Eaton. She brings a strong technical foundation in material science and a passion for advancing metal additive manufacturing. Research and professional work has centered on understanding thermo-mechanical effects in titanium alloys, as well as the broader thermodynamics and stability of phases in high-performance metals. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials qualification or general additive manufacturing support, or want to learn more about our quality management tool, TraceIM, reach out to the team or through our website or via email at info@3degreescompany.com. All right, Sabina, thank you so much for joining the show today. Really excited for the podcast. And yeah, like we'd start with most of the guests, let's start way at the beginning. Where were you from? Where were you born? Kind of, do you have some early inspirational memories about engineering and kind of what got you on this path?
Sure. Well, thank you, Mike, for having me on your podcast. It truly is a privilege, and I'm looking forward to share insights on additive and just my journey through it all. Started all the way back in India. I was born in India in this tiny town called Ooty. It's actually a very touristy town back in India, just because if you go back to the history of that town, when the British were in India, they really loved the place Ooty because it was situated on the hills. So the weather in that area was very similar to the weather back in England. And so they settled quite a bit over there. So we have a lot of British influence in my place.
So when I think of British weather, though, I don't think of nice weather. I think of rain and cloudy. Is that what they were craving?
Pretty much, but it was like the 60s and 70s pretty much throughout the year.
So not super hot like in other parts of India.
Not super hot. Very, very beautiful weather, and it's on the hills, so the climate and the atmosphere was so beautiful that we have a lot of tea estates. So one of the major industries in my place is like tea estates and the production of tea. So I'm a big tea fan. Cannot go a day without tea, and the very typical tea with milk and sugar, so it gets spoiled. So then grew up, did all of my education back there in Ooty, and then when I had finished high school and was thinking about college, I knew I wanted to be in the field of engineering, but I didn't have a specific path forward. I didn't know if it was software or mechanical or materials. And then one of my uncles, who was also in the field of engineering, and as we were looking through the options, I had software available, I had mechanical, and then I had this very specific engineering route called metallurgical engineering. And we were just discussing, and we were like, well, let's just go and give metallurgical engineering a shot. It's not the very popular choice for women engineers specifically. But he said that, if you are interested in the metals world and if going down and exploring metals, then this is a really good field to take in, because every metal issue, if you look in the industry, comes down and boils down to the microstructure and the very metallurgical features of the material. So we thought, let's give it a shot, and that's how I stepped into my first venture in engineering and material science. So it was in metallurgical engineering specifically, very niche field, but it was a really interesting field to explore. There was a lot that I learned about some of the things that I use on a daily basis over here right now in my job, from heat treatments and how the material behaves at different temperatures, and some of the materials testing that we do, and why do we do those materials testing, for what purpose, for understanding what material property and things like that. So it was a really good foundation to start off with. So I did that for my bachelor's, and then I moved to the US and then did my master's and my PhD. And that was when I got the chance to step into the field of additive manufacturing. Specifically, worked with one of my professors in the University of Tennessee, Knoxville. So they had a good establishment because the materials department worked closely with Oak Ridge National Lab at that point. And their manufacturing demonstration facility called MDF was initiated and was growing. So there was a lot of growth happening at the same point. So it was a good time to step into the additive field at that point. So a lot of my research work was in additive, and that's how I stepped into additive as a materials engineer.
And so you said you kind of knew you wanted to do engineering, not what type, but why engineering in the first place?
That's a good question. One, it's the very typical kind of stable field that will grant you independence and will grant you a future. I have always been inspired by my mom. My mom has been working through her life, has been very independent, and she's not an engineer, but in the field that she was in, she was very proficient. And the same way, my dad was also working, but not in it. Was he? I think he was in telecom engineer or something, but still in the field of engineering, but was working very independent. So I grew up in a household with very driven parents and independent parents, and I always admired that in them. So I always knew that for my future, I did want to be in a space where I am able to drive my future. I am able to be, independent, financially independent, and I am able to be in a position where I am intellectually challenged every day. I really love that aspect of working. And so I knew engineering, regardless of which field engineering was going to take me into, there is always that opportunity for growth and for finding out a future for yourself. So I thought engineering was, if I have to put it in very layman's terms, was a safe choice for what I was thinking that I wanted in my future. But yeah, that's why I chose engineering. And I didn't want to do anything else because like the finance work was a lot of math. The doctoral work was just too much study. I thought engineering was a good middle ground.
Yeah. So did you like math and science kind of growing up, like taking things apart, or did you have any like other interests or hobbies that kind of related to what you ended up doing now?
I was just generally interested in like chemistry and maths. Yeah. I think those are two like good drivers, because just the complexity of like adding two elements and then something new comes out was very intriguing to me. And I think it's the same field that we work in right now. Add tools to combine a couple of elements, and then you get this really neat alloy that you can do really fancy things with. So I think generally chemistry was just an interesting subject to me. Math, not so good. Like math, it was okay. Like I wouldn't really dig into like the specifics of math, like the basic math that we need to do. I'm a little bit interested in that, but it's not a big driver for me.
Yeah, and for sure, it's one of those things too, right? Just because you're a chemical engineer, materials engineer, or computer scientist, or whatever it means, like it just kind of establishes that you know how to think and problem solve, right? So you could be a manager, you could work in recruiting, you could work in project kind of development and things like that, and also in the lab and doing the technical things. So it kind of gives you a lot of good foundations to jump off from. And so what was it like kind of coming to Tennessee when you first kind of started doing it was your master's and PhD, right? That you kind of were there. So what was that like?
It was very interesting. So actually, when I moved to Tennessee, I had just also recently gotten married. So it was all
the big life changes.
Yeah, all the major life changes. Like culturally, there's a big change between coming from India, being born and brought up in India, and then coming over here. But then I think language wasn't that big of a barrier for me, because when I did all of my education, we did it in an English medium school, and all of the schools back in Uti also were British established. So we had a lot of like the Western influence in growing up in itself. Like I grew up, actually, another interesting fact is I grew up in boarding school for a bit. I loved it. There are people who have opinions of it, but I just loved boarding school. It was the most fun place to be at. And I think that's also where a little bit of my independence, a lot of my independence grew, because you got to really be responsible from like making your bed in the morning all the way to like discipline all the way to the night, right? But you still have your fun as it comes with boarding school. So I did a little bit of my so all of that really built in my independence and helped with my language skills. So coming to the US, at least language wasn't that big of a barrier for me. It was easier to communicate and gel in with the people. But it took quite a bit, because I just got married. So it was getting that settled in, and then getting settled into a new place and learning how to navigate, how to like do shopping. And in India, you never fill the gas in your car, so someone always fills it for you. So it was here, okay, figuring out that I have to like fill gas in my, it's like the small tiny details, right, that you don't realize. And then I also had to like figure out driving, which is driving in the opposite side.
Oh, right. Yep.
From India to the US. So I was getting used to that, getting used to like the whole shifting of the gears and everything. But in India, I drove a manual shift. So I was very used to like handling a car, because they didn't have automatic cars at that point, I guess, or maybe I had just a manual shift car. And so coming here, I had to get used to the automatic shift. Plus, like, even I think in India, and this is really sad to say, but in India, I never knew the concept of a blind spot. Like, a blind spot was never something that I was aware of while driving. But I was a safe driver. I didn't have any accidents when I was driving for my 2 years in India. But when I came here, like my husband always would tell me, check your blind spot, check your blind spot. So it was something that I had to learn. But then at least getting my license was pretty easy. In Tennessee, in Knoxville, Tennessee. But that gave me, again, a little bit more freedom to explore the outdoors and explore grocery shopping, explore different places. So I did a lot of work with my church at that point, because I took a break year. And I think it was really helpful taking a break year, because the year that I came, for 1 year, I just spent time with my husband. We went vacationing, we went to a couple of places, and then I was just doing hobby stuff that I like doing. So I volunteered with my church quite a bit. And then it was after that first year, and then the fall of the second year, that I joined school. So it was good that I had that 1 year too. It was like a good reset for me, having such a big move and a major life change as well.
And did you know was it a thesis focused master's, or did you know what you wanted to kind of focus in on when you came, or was it kind of exploring a little bit?
Not really. So when I got into the program, I wasn't really aware of what was the hype, what was new in the industry and everything. But then I was just Googling what the materials department looked like in the University of Tennessee, Knoxville. And I realized that a lot of the materials department folks worked closely with Oak Ridge National Lab. And then I realized that additive was one of their bigger joint programs that they had. So that's when I reached out to one of the professors and asked them if they had any availability, or if they were taking in students and were interested, because I was interested, coming from a materials background, from a metallurgical background, and understanding how the material behaves in this very complex process, but also newish process that seems to be growing. So yeah, that's how I got into additive manufacturing.
Do you remember the first time seeing a machine?
Yeah, as soon as I joined the program, they gave me a tour of UT, but they didn't have any machines over there. And then they gave me a tour of the manufacturing demonstration facility. And gosh, they had like RCAMs. They had the two ePBF systems, the RCAM and the RCAM Q10 Plus. So they had those two, and then they had a binder jet machine. They had a Renishaw machine. So it was all of the big additive machines that were like full-time, big horsepower, actually running materials, and it was like pretty cool. It's like, okay, this is a very interesting field to be in, I guess.
Were you running your own builds? Were you kind of operating machines as you got further along?
So in my field in additive, I work more from like a materials point of view.
Okay.
So I didn't do a lot of builds. What I would do, but my research mainly focused on understanding the material behavior on like the micro scale dynamics, seeing how these phase transformations actually influence the material behavior when you're like heating and cooling, and then with multiple layers, there's still an influence of the temperature and the temperature reversals, like layers below it. So understanding from a very voxel size what is happening in the material as it fluctuates these temperature profiles was my main thesis research. And it was actually very interesting because the project that I got into was a multi-university research initiative. So it was this big naval funded project, the Office of Naval Research funded project that had about 8 universities all across the world looking at understanding the basics or the fundamentals of what happens to a material when it is additively manufactured. So we had a couple of materials that we were looking at: Ti-64, Inconel, stainless, I think some stainless steels as well. But this also gave me a good platform to like build my social circle, because we worked with Colorado School of Mines, we worked with universities in Australia, University of Sydney, and Sydney University, and so many universities across the US as well. So it was really nice to be in a collaborative project that you get to meet other expertise, and you also get to see what special materials, material department facilities other universities have. So it was, I really appreciated the thesis project that I worked on. Just one, because it was a big initiative and it had like a really good circle of engineers working towards solving this problem. So it gave you insight on every specific detail other team members were doing. And second, it was just interesting in itself.
And what year was this, or around what time?
2017.
Okay.
2017 was when I started. Yep.
Awesome. And so as you're wrapping up your PhD, did you have all your ducks in a row? Did you know what you wanted to do next? Were you thinking academia? Were you thinking staying in additive, not staying in additive, going into industry? I always love to ask people kind of that. What was that transition like? Because sometimes after PhD, it's a little bit wonky, right? Like you're trying to figure out kind of what to do. And
very much. After PhD, I knew one thing for sure. I did not want to get into academia. I was like, I am done with studying, and like even teaching or nurturing someone else is like, it's not my strong point. I feel like I'm more of an individual contributor. I like collaborating with people and working together as a team, but then I really cannot see myself growing up like in the manager, or like, I'm not very people oriented in like the workspace. I'm an extrovert, but like on the social scale.
Sure.
If that makes sense. Yeah. So I knew I didn't want to get into academia. But if academia opened a really good position or an opportunity came along, then sure, I think I was able to like put in that effort into doing that. But then I did make sure that I wanted to be in the field of additive manufacturing, and I wanted to go into industry. So it was interesting because a majority of my research years was COVID, and then we were like doing a lot of work from home. So had to like balance out the time that I went into the lab and then make sure that it doesn't overlap with people, and just like, it was a little bit hard to navigate during the research work during the COVID time, but my professor was very supportive and very helpful in those times. So it was easy to get some of the work that I wanted done. And then so I knew industry and then additive. After I finished my PhD, I did not have it all together at the end of it. I knew I wanted to finish off in like 4.5 years. So I did that. I finished. I got my goal achieved. I finished. I passed my PhD. And then it went into the job hunting era. It took me about a couple months to figure out what I wanted to do, apply for jobs, get rejected a couple. And then I was also very interested in just the Detroit area, because my husband was already here, so we knew that I wanted to be just settled in the Detroit area. So
so you guys were you doing long distance the whole time, or like pseudo because COVID? It was kind of weird during that time.
Pseudo for a bit. He was there with me for the majority of the time, and then around the COVID time was when he moved over here. So it kind of was convenient because we had to stay at home anyway. So I was in Detroit for a bit, but then I traveled back and forth from Detroit to Knoxville a couple of months, and yeah, it was fun. 8.5 hours drive up and down. So
probably drive right by us. So here in South Bend.
Yep. So we did that for a while, and then I knew my husband was here in Detroit, and I wanted to be in the Detroit area. Plus, I also know like Detroit is the automotive field, and I knew GM, Ford. I don't know if Stellantis at that point was doing any additive, but I knew GM and Ford were like heavily invested in additive. And then I knew there were other smaller companies that were also invested in additive in this area. Like for instance, GKN, we did back in grad school. I know that GKN worked quite a bit with Oak Ridge. So I knew like GKN also was like a big player in additive. But it took a little bit to find a job in additive. I also had to like scale it down back and say, okay, if not additive, I do want to at least be in the materials scope. Like I don't want to deviate from that. And then this position opened up at Eaton. I remember I was almost at the end, and it was just like giving up on the whole job search because it was like mentally exhausting. Plus, I just finished a PhD, so it's like, well, okay, what's future? And then I applied for this job at Eaton that I am at right now, and we went for a break. Just shut it all out and then went for a break. And in the middle of the vacation, we were in the middle of the forest, and then I get this call from someone who's like, hey, Sabina, so we saw your resume, and I think we're interested in learning a little bit more about you and how this job can fit for you. So I was like, whoa, okay, I'm in the middle of vacation. Can I call back after a week? And luckily, he was also on break the next couple of days, so it perfectly worked out. And then after a week, we got together. And and that's how I got landed the job at Eaton.
Awesome. So what do you do? What is your role, or what is kind of the big picture with Eaton as well? Like what do they do? What's their focus for people who may not be aware of the company?
Yeah. So Eaton, if I have my slides, Eaton is a global power management company. So we do a lot of power management. Our major business is in the electrical sector, but we also have our industrial sector business, under which we have the e-mobility, aerospace, automotive industries. And so our bigger chunk is in electrical, and we do have our industrial sector as well. Where I work is in a research and development facility here in Southfield, Michigan. So we are a corporate funded facility where and specifically if the place that the team that I work with is under the advanced manufacturing team. So what we do over here is research and development work across polymers, composites, manufacturing processes, and then additive manufacturing, and then even some digital design work that we do. So I work more under the additive processes. I am a specialist engineer here at Eaton. And with my background in materials, as a materials engineer, I work more in the metal additive space, trying to make sure for the processes that we invest in that we think that would be beneficial and profitable for Eaton, for some of the additive processes specifically. So I work in the materials maturation and development of those processes. So making sure that all the materials data is collected and is performing well, doing some process capability on it to see that the process is a capable process. So what we do is do all of the early TRL, MRL maturation of a process before we then deploy it down to a production base within Eaton. So our facility was established, our additive facility specifically was established around 2016, so way before I joined Eaton. And then ever since, we have been able to drive an application to actual production. Right now, if you look, the scavenged jet pump, there's a metal AM, article about it, about one of the production parts that we have. So it's out there, and you can. And so that was early developed and started in the Southfield facility, and then that propelled Eaton to go and invest in an actual additive manufacturing production facility. So that's down in Charleston, South Carolina. And that's our aerospace additive manufacturing facility, where they actually have a couple of production parts. So it's an actual production facility, certified, NACAP certified, and it has its certifications for production. So they have a couple of production parts, and they deal with more of the once a process and a application is mature is when it goes to the production facility to then continue production. And then we do some of that early TRL, MRL work.
And so from your perspective, I mean, you don't have to get into specifics, but like what are the concerns that people have when it comes to additive? Is it similar to any other kind of new process, or what do you see as kind of the key sticking points that you're kind of in the weeds on every day of trying to make sure that parts are safe and parts are made high quality and repeatable?
Yeah, I think you just said it all right at the very end. If parts are repeatable, if the material properties are repeatable, and just making sure that we are able to fully understand the process and make sure that the process is performing at that 100 level, or like the 80 or 100, wherever you say that it's performing, but it is performing consistently. I think that's one of the biggest issues that we've been having. Plus, additive manufacturing is more of a newer technology compared to some of the conventional manufacturing process that we have right now. Even if you look at binder jet, which is very similar to a MIM process, it has its own specific, unique pointers of why it stands out as an additive technology and its unique features that it has. So maturing that process takes a lot into understanding how the printer works and how the part then sinters, and how do you get from your green part to your final part, and maintaining that tolerance and the dimension, and making sure that you have a stable process. So all of those very detailed things we don't have a lot of knowledge on, and it takes quite a bit of time to mature that process. So I think the early MRL levels of like 3 to 6 is a lot of work to get to the maturation of a process that I think we as an industry are getting to a point where we have more globally accepted standards of getting to that point. So it is widely acceptable to different industries as well. And I think that was one of the hurdles that I've seen in the adoption of AM. It's just there was no wide acceptance of the data. But I think, again, with the project that you and I are going to be on, it's nice that we have a platform where we have platforms that are looking into establishing more widely acceptable qualification procedures. So there's a common understanding that this data is valid, and this data has been collected from valid sources, been tested at valid sources. So you have more confidence in the data that you build.
Mm-hmm. And first,
I like that trajectory that we're going in. Yep.
Yeah, and maybe from the perspective of someone who's fairly new to metal AM, maybe familiar with like something like a bamboo or something like that, or just maybe traditional manufacturing. What are your top 3 kind of considerations when you're thinking about material characterization, material testing, that you're looking for? You're just kind of keeping in the back of your mind of say, okay, hey, this part we can get there, or this material we can get there, or this process. Like, what are those? Like, what's your kind of mental model when it comes to metal AM?
Yeah. So yeah, coming from the materials point of view and collecting a lot of data, I think understanding that the material density is at that 99% or 99.9% is critical. So that just talks about how the material of the part quality. So that's one of the biggest things that we collect right off the machine when we get the parts, making sure that the density, however you're collecting it, if you're doing an Archimedes method of collecting your density, make sure that you have done a gauge R&R study to make sure that the density that you're collecting is within acceptable limits. If not, then okay, do some metallurgical cut-ups to take some optical microscopy. So you
What
have
do you
a more
typically see
realistic.
as like your warning sign? Is it 99? If it's 99%, but not 99.9%, are you starting to do cutoffs? What do you think is like, do you have an idea in
Yeah.
mind where you start to?
So for some of the processes that we have, what we build is called a minimum allowable.
Mhm.
And so when you have collected enough sufficient data to qualify a machine and a part, then you keep that as your point of reference. So if your point of reference is 99.8% with optical porosity measurements, then any other data that you collect from that machine should hit that 99.8%. If it doesn't hit that 98.8%, then you have an issue. There's something that's up with the machine that needs to be checked out and looked at that point. So that's another diligent step that people in the additive scope has taken to make sure that we define our minimum allowables for a process, for a part, and a material. So you have that as your baseline and your guidance to make sure that your machine is performing well and your material is performing well. So if it doesn't, then it's one of the two issues, like something's up with the machine or something's up with the material feedstock at that point. So it's an interesting way to go back and dig into what actually is the problem. So density for sure is one thing that we collect. Tensile properties at room temperature is also another good gauge to make sure that the material is performing well, especially with some of the additive processes that are very they're very dependent on the way they are produced. So for some of the metal AM processes like the laser powder bed fusion and the electron beam melting processes, they are very dependent on the grain growth direction. And so they have been processes to make sure that the material is more isotropic and it has equal materials in the XYZ, or if not, you have your minimum allowables that you collect for your Z direction versus your X and Y direction, so your horizontal versus your verticals, and then you keep that as your baseline and make sure that your tensile properties are behaving accordingly. So those are some of the one of the two major checks that I would do, and then from there sometimes it gets very specific on the application. So if your application is a critical application for fatigue, you do want to collect a couple of fatigue points and make sure that the mean curve that you generate it compares well to the mean curve of the data that you collected as your reference, and then also your minimum curve, your minimum allowable. You do a regression analysis to get your minimum allowable and make sure that minimum allowable is within the reference that you collect. So then you're confident to say that the print was good, the density is good, the surface looks good, and your fatigue properties is performing well. So we have a couple of applications that are fatigue critical. So we do a couple of checkpoints to make sure that those data points and the mean curve that you're getting is within your acceptance. There are some applications that aren't fatigue critical, but could be a corrosion environment critical application. So then you would do your SEC, your stress corrosion cracking tests, or you would do an anodizing and make sure you collect some data on how your material behaves. So yeah, I would say like the third testing that you would do would be more specific to the application that you're working on.
Yeah, that's a really good way to put it. So just a couple more questions as we kind of wind down the discussion. So one is kind of thinking back on going back to that transition out of PhD, or kind of early on thinking about what you want to do with your career. How has your initial perception of working in industry compared to the realities of it?
Actually, it wasn't that bad, because I wanted to, in my mind, I wanted to be in a place in additive that was actually working on applications that was going somewhere. It was just not like a research application that then sat on your desk, or was a really nice, very cool material composition that you did that goes into a very specific thing, but then it doesn't go on from there. You don't have a business that buys into it. So I wanted to be in a place where, that application is actually transferred on to somewhere. It goes onto a system, it goes onto an engine, and there's a future for it. So the work that you are working on is going somewhere. So Eaton was a really good space to be in at that point, because at that point, Eaton was actually driving applications that benefited Eaton and went onto an engine, went onto a final product, and so there was product testing done, and it was very interesting to see, a part actually come to life. And even though we did not work on like the very specific alloy combinations or like some of the new HEAs, like the some of the very nicer alloy combinations that give you specific material properties, but all we worked on was like the Inconel 718, which has been worked on like quite extensively at this point, and like the stainless steels. But then it was a different experience of like, all right, we know it's a commonly accepted material. Stainless steel 316, for instance, is a very commonly accepted MIM material plus an additive material. But then you don't understand how much it takes to like mature that material with a process. Just from MRLs 3 to like 5 is so much that goes into like maturing that process. And it was interesting to be a part of that process. I have learned a lot in like process capability studies, like the gauge R&R studies, to make sure that the data that you're collecting is repeatable and is reproducible. So some of the design for Six Sigma principles that you would otherwise you would not apply outside of an industrial sector, or would not be very applicable outside of an industrial sector if I looked at it, was something that I learned being at Eaton. And I think it's a very valuable tool to have when you are looking at maturing a process, or when you talk CPK and CP analysis. That's very relevant to like for industrial maturation. That was something new that I did not think I was going to get into, but it just defines how well you know a process, and how well it takes to like mature a process in terms of like the material and then the overall process specifics. I work more on the material side. I don't do the overall process, but we work as a team, and we have team members that work on the process and collecting the data on some of the process specifics. I collected more on the materials, but yeah.
So just two more questions. So one, what are you excited about in the next 6 months, whether it's related to the work you're doing or work that's kind of coming up, or trends in the industry? Is there anything that's really exciting on your radar?
Question. For those who don't know how we got together, I think the one platform that I came to know Mike was from one of the America Makes proposals that we were going after, and we needed a data management solution. And at that point, I had like, what I had no idea what they wanted when they were looking for a data management. And that's when John from EOS introduced me to you, and that's how I got to know you, Mike. So I'm really happy that we crossed paths that way. And then I'm excited in the next 6 months, because I know that program was a win, and we are going to start that program pretty soon. So I'm excited to get that program initiated. It's actually like my first big win for a competitive proposal in my industrial space. So pumped about that. Plus, I'm also excited to actually see what a data management platform looks like and utilize one of those, because I have been doing all of the data management on my end just like solo, and it's been on just my hard drive. So I'm really looking forward to see how we can use tools that are available out there for managing all of that data. So I'm excited about that. And then, yeah, I just got a couple of programs that I'm going, that I'm working on, that's going to be reaching some really good milestones. So with this year, I've been a PI on one of the programs. So it's really been nice leading a team, getting that exposure to leading a team towards the completion of a program, like hitting milestones, making sure the team is on track. I think that was it was a step up from what I did when I first joined Eaton. Still more on that individual contributor track, but then it's still leading a team towards the end goal. So that was a nice challenge to also have, that I look forward to in the next 6 months, as we have some critical milestones to hit.
Awesome.
Yeah.
And so last question, more of a fun one. What's a book, podcast, or something that you would recommend as something that has been impactful for you, whether it's you liked it or you learned something from it that you'd like to share with the audience? We compile a 3 Degrees discussions book list at the end of the year. So what would be your contribution? to that?
All right, so I'm not a big book reader, but then I have found Libby, which is the library app where you can borrow books and then listen to it. So I was a big podcast fan, and then saw the podcast, and then I got into too many true crime podcasts. Then it just messed up my whole like suggestions also on the podcast. So I quit that for a bit, and then I went on to Libby. Have been listening to a couple of really good books. The one that I recently listened to, and it's not a new book, it's a pretty old established book, was Atomic Habits by James Clear.
James Clear. Yep.
James Clear. Yeah, I mean, I was listening to it. I listen to it every day on my way back from work, and my commute is like a 30-40 minute drive. So it's a good chunk of time that I get to spend on the road, that listening to some of these books. And listening to it was a couple of hours. So I finished the book pretty quick. But it was just very interesting. The actual fundamentals and like some of the scientific details he went through in his book on what it takes to like make those small changes in your life and how they impact your life to the end. So Atomic Habits is like one of my all-time favorite books right now. Have been using a lot of principles from the book in my day-to-day life, specifically, you know, not procrastinating, making sure that like the smaller things of like keeping the kitchen sink clean in the night before you just go to bed, like spend that extra 10 minutes to just get that cleaned up. Just takes that extra effort, right? But I think once you like make it a habit for a couple of days or a couple of weeks, then it just gets into your mind, and then you cannot not do that without closing the day. So yeah, Atomic Habits was a really good book. I would suggest for everybody who is trying to figure out how to I don't like using the term work-life balance, but how to like manage your work life and your home life and your personal life. I think that's a really good book that gets you encouraged to like think from like the very small habits that you get yourself into, and then how it just leads to like the bigger picture and your bigger goal.
Awesome. Cool. Well, thank you so much for joining the podcast. We're excited to work together with you guys as well. And yeah, look forward to seeing you in the coming months here as we wind up 2025.
Yeah, me too. I'm excited to work with you and the team, First America Makes project. So looking forward to it. But yeah, thank you so much, Mike, for having me. I really enjoyed talking to you as well. But yeah.
All right. Take care.
All right.